Hey, welcome back to Engineer's Workshop. Just playing with the Cincinnati a little bit with the Brown & Sharp magnetic chuck on it, using it as a surface grinder to prep up some small steel chunks, turn them in from scrap into usable pieces. Got a couple of projects I'll preview with you later. But basically I wanted to get back on the Abrasive number 1.5 surface grinder, continue the restoration work on that for the small items that get the table feeding front to back, the wheel guard. They're going to do a little bit with the spindle, the run out in the spindle that I identified. So let's get back on that and pick up where we left off. To move the table front to back, there is a lead screw with 1/4-inch pitch driving a bronze Acme nut. That's all in a self-contained housing that plugs into the front of the machine. And then to drive that, they've got this pretty nice little gearbox. And this is shown upside down, so this actually bolts onto the underside of the table onto these 6 locations here, with a couple of what I assume were locating dowels, which are no longer in place. But back face is machined where the contact surface is. This surface here, really not machined. I mean, that's kind of, feels like an as-cast surface to me. And this was all grease lubricated initially. I'm not going to do a full restoration on this, but I really can't leave a gearbox of any kind packed full of dried grease and grit. So there's the actual drive gear is in that bore there. There's 2 bearings with a spacer. And so that's very nicely supported. And then with a Woodruff key on the end, which was not present. I ended up getting a couple of Woodruff keys from the local Ace Hardware. It's held on by the hand wheel, which is graduated in thousandths, 250 divisions around the perimeter of this wheel. So it's a 1/4-inch per revolution. Wanted you to look at this this nut that captures the end of the shaft. This is one of those examples of really nice design and engineering. There's a flat step, the entire diameter there of the hex, relieved slightly so those points don't dig in, just 5 or 10 thousandths or so. And look at that really nice, kind of like a spherical dressing on the outside of that. Just, nice touches like that on the old, war and post-war machines. So I am going to give this a coat of paint, just, not a restoration quality, but since it is clean, I'm going to paint this with Rust-Oleum Machinery Gray. See, it looks like, is that it might be a plug from the back side so that they could through drill that hole. Yeah, that's what that is. So they drove a plug in so they could through tap it. I can't see evidence of that on the upper holes. And the pointer on this is positionable so that you can zero the hand wheel wherever you want and then lock that in place. Both of the shafts, or the bearing sets in here, have oilers, little oil cups. This was grease, but what I am going to do, I believe, is I'm going to put a bead of Loctite 574, the flange sealant, on this. And then when I put the back cover on, and this thing is upright like this. I'm going to call it semi-sealed, even though that surface is not, a fully machined surface. It should be oil tight enough to hold a small amount of oil in here. And then I'm just going to use the oil that I use for the bearing sets, maybe pre-fill it a little bit to oil the gears. That way it won't get caked with grease. And if I use a non-detergent oil, any grit that does get in here will settle to the bottom anyway. So that's the plan for redoing this in the short term. I know I said I was going to seal the backside of the gearbox to the unmachined edge, to the machined perimeter of the actual cover. I thought better of that. It looked like it was something I could tackle and actually mill, set it up in the K&T and mill that edge so that it was flatter, because there was a little bit of a rock when I went and I put the back on there. And that Loctite 574 is not the best for gap filling. It's more of a metal to metal contact, gasketless adhesive, and it works really well for that. But I wanted to make it a little bit closer fit, so I set it up in the K&T, and let me show you how I milled that piece. So here's the setup in the vise. I got a piece of 1/2-inch plate. It is exactly the right height that I need, and roughing end mill long enough to get that perimeter. I'm going to have to move this clamp, but I'm just going to check and see that we're basically level to the table, and then dial in a light cut and make a machined gasket surface on this rough casting. Slow that down a bit. Well, with everything lined up square to the table, there's about a 10,000ths difference between the height of this point and the height of that point. That point is a little high. This is low by about, 20 or 30 thousandths, probably because of, draft and the way this thing was cast. So I'm going to pick an elevation that starts to clean this up, and then live with how much deeper it gets up here. It's really not going to be that much. So we'll get just a nice clean up here on this outer edge, and then a little bit deeper as we come into the front. We're touching it at 30 thousandths. We're not really removing much. Right now I have a difference of 40 thousandths from where the cutter is to just touching here. So that looks like that's our magic amount. Let's come back and get this little bit that didn't clean up here. We'll work this end first because this is more rigidly supported. I'm gonna have to take that other clamp off. I'll add one here and maybe put a clamp on the underside so this thing can't walk down. Go in just a little bit more.
have to shift my work here another 1/8 of an inch to get that corner wiped out. I have to get the rest by hand. As close as I dare get. That's pretty good. That'll do what I want it to do. I've got my gearbox somewhat reconditioned, machined this surface to accept the machined cover. And so now that fits up real nice. In order to install this, I'm going to use a bead of Loctite 574 on this lower edge so that, and actually up here too, so that this thing can keep oil in the bottom of it and lubricate the gears. In order to assemble it, I'm going to have to temporarily utilize this hole. It's kind of odd. They only show, or they only use 2 1/4-20. I believe these are called cheese head screws. It's a slotted screw, but it mimics a low head cap screw. And so those go up there, and then there's a 5/16 threaded hole here with no fastener. This actually accepts, there's a long threaded rod with a jam nut that goes on here, goes back inside the base casting of the machine. I'll show it to you there. And when you move the table out, that acts as a stop to prevent this from going out too far and letting the worm disengage. So temporarily, I'm going to have to put the cover on and just put a 5/16 cap screw in here to clamp it and activate the Loctite gasket material. Then this will get replaced with the threaded rod once it's bolted on to the underside of the table. So this is the table, and this is exactly where this goes, right like that. And so, you crank here, the threaded rod comes out the back and pulls the table back and forth. So this is the underside of the 4 1/2 table, which holds the gearbox. That gearbox bolts onto this location. And originally this thing was held to the table and also the feed tube with slotted screws. I believe these are called cheese head screws. And I'm only really able to find them in metric. These are 5/16. But you can see those fit that counterbore really nice. Now, at some point, they must have lost some of those, and what they ended up substituting in their place were what are commonly referred to as low head cap screws. And if you look at the low head cap screw, it's very similar. And it also fits in the counterbore. You know, dimensionally, if we look at these, the cheese head has a diameter of about 425, and a low head is about 433. The height of a cheese head is 182, and the low head is 155. The thing I hate about low heads is the tiny size of the hex, the drive size on these. And the problem is they install when they're new, and you tighten them up and you follow the specs, everything's fine. But then these things sit in the, you know, in the assembly for 5 years, 10 years, 20 years, and you go to remove them, and you know, the rust bead that locks that diameter in place out here cannot be overcome by the size of this drive, and you cam out the head. So we end up drilling these things out all the time. I avoid these like the plague, but you can't, like I said, you can't really find these. You know, McMaster has metric ones, and the English ones they have a dome. But in my day job, I engineered a replacement for the low head cap screw by using a button head cap screw. Now, button head cap screws are normally only for attaching like sheet metal and guards and stuff like that. They're not considered a high strength fastener, but really neither is this. And all of the installation torques basically go by the size of the drive. Now, the nice thing about the button head is for a given size screw, it gives you a larger hex. So this one is a 3/16, and this one I believe is 5/32. So the challenge is to turn this into a fastener that will fit those counterbores. Very simple to do. You take the OD of this, so 435, and that's, you know, 535. So you basically take 100 thousandths off the diameter, and if you really want to get finicky about it, you know, you can take the 155, or in the case of the cheese head, the 185. And if we look at the head height on this, you know, hell, it's actually not much bigger. It's hard to get it because it's smaller than the diameter of the screw. It's about 170. You know, I have taken a very light cut off the top of these to match the head height of the low head cap screw. But, you know, in this case, we can just put these in the lathe, take 100 thousandths off the diameter, and then they'll drop right in here, and we'll have a bigger hex key when it comes time to remove them. But I'm also going to go with stainless just for grins, because, you know, putting the stainless fasteners in will prevent any kind of corrosion from happening to this guy. So let's take this over to the lathe. We'll make some duplicates for usage where we've got these, and I'll keep the original screws where I can, but we'll make a few of these for replacements for the low head cap screws. Okay, I've touched off on my diameter, so we need to take 100 thousandths off the OD of this head. And there we have it. You can see my oil hole here, which lines up. Unfortunately, on the back side, you can't really see it that good, with a hole through the base. No physical connection through there. The only way that I I've really found to hold this is to use the screw temporarily to pick it up, because it just wants to drop in the back. Until the dowels are started. This screws into the back side of the gearbox and bottoms out on the casting if you try to go out too far. This is a 1/2 inch, just a 1/2 13 set screw plugged into here. I have no idea if there's any function to it. The hole just goes through the casting.
Spent a little bit of time working on the one set of centers for the number 2 tool and cutter grinder. This quill was really stuck in here, and it wasn't so much the quill lock, which is this little scallop piece, has a cut in here and it binds against the side of the quill, as it was just the general, rust and corrosion that had developed on the body of this over time. Now, these 2 knobs lock it into the T-slot. Just basically pull it forward, or I guess, no, it pushes it back against the back side of the T-slot by pulling clamps this way. But what these did not come with was a clamp for the quill. And so I found a twin, big brother to these off McMaster, with a 3-inch threaded stud, that with just a tiny bit of work on the OD here, because that's the same diameter as the little lock piece, will serve as a means to lock this in place. Unfortunately, I'm going to have to show you the underside and what I am lacking. I'm going to have to get the camera just right. Now, if you look down in there, you can see where that stud will come through, but that's just up inside that casting. And that's all just a rough, as cast surface. So I really don't know what the lock mechanism would clamp against. But the little piece of steel that you saw me working on earlier, I'm just going to turn that into a little bar. I might have a stub that projects up into that hole a bit and serve as a means to center it up. And then the casting itself will prevent it from rotating, but combination project for the K&T and for the lathe to make a pair of just retaining nuts to go inside these castings and let me tighten down these quills. So that'll be an upcoming project. I hope you enjoyed that continuation on work for the Abrasive number 1.5 surface grinder. Just keep pecking away at that one until I can get that back in service. Having fun playing with the tool and cutter grinder. I will get this chuck transferred over to the surface grinder once that's running, and regrind the surface of that true to that table. We've got some K&T work coming up. Projects for this and for the abrasive machine. Got the internet saga going on. Fiber is pulled from this building to my small shop, and we're working on the last stretch from my small shop to the house, which is the 380 feet. And I've got an existing black poly line underground that we've got to fish that through. Got a pull string in there from one end to the other. Now we've got to pull the 2 strands of fiber cable from the small barn over to the house, and then I'll start terminating that fiber, which, whew, boy, that's some fine stuff. I'll probably put some videos out on that too, but anxious to get this fast internet service from this building over to the house where I work 3 days a week from home. So thanks again for watching the content here on Engineers Workshop. Sorry for all the background noise. It's just a rainy, miserable day here today. But hey, you work with what you got, right? So back next week with continuation of the projects. It's Thanksgiving week, so hope everybody, let me think, is this gonna be out after Thanksgiving, so I hope that everybody had a great Thanksgiving holiday, saw their families and ate some turkey or whatever else that you eat on Thanksgiving. And until next time, as always from Engineers Workshop, stay safe.